Entonces, that means que the lecture is split into video. Pero no worry, I collect both video and I post in YouTube, ¿no? Entonces, nobody click, please, the button record. Because you are living in the lecture, entonces automatically the action of recording is stopped. Okay, okay, do you understand? Okay, this is, you are a new student in this Skype maybe, entonces you don't know that part. Okay, so let's focus it, as always, in the expression inside the radical. Yes, this expression. Negative 2 squared 4. Be careful with the sign, double negative plus 12, no? Because 4 times 3 is 12 plus times 1, but it's negative positive is 16. And when you apply square root, it's 4. It's 4. So far, we have 2 plus or minus 4 divided by 2. The 2 plus 4 over 2 and 2 minus 4 over 2. 2 plus 4 is 6 divided by 2 is 3. And 2 minus 4 is negative 2 divided by 2 is negative 1. And this is the answer. No, of course no. Because I recall something. Look, we have the original equation in black color. We create, for solving this, a new equation in red color, is quadratic equation. That is the reason I'm using the quadratic formula. And the value that you get here is u value. U equal 3 and u equal negative 1. But I need x. See, I need x value. I use in this substitution. Okay, in this moment you split the paper into parts. Split the paper for u equal 3 and for u equal negative 1. Okay, wait a second. 2 minus 4. 2 times 2. I forgot something here. I forgot. Sorry. I forgot something. Wait. This is wrong. I suppose it was the problem with the recorder. I don't pay attention. Because A is 3, no? Look. So far it's okay so far. Okay, A is 3. Yes, so it's 3 here. 3. Entonces 2 plus or minus 4 divided by 6. 2 times 3 is 6. 2 plus 4 over 6. 2 plus minus 4 over 6. This is 6 divided by 6 is 1. And this is negative 2 over 6 is negative 1/3. Okay, u value and u value. I need x value. So see, I need the x value. Well. I split the paper into parts for u equal 1 and for u equal negative 1/3. But who is u? U is x squared. Okay, and so in this moment I have two equations, two quadratic equations. Easy. Okay, we can solve them by square root method. Square root both sides. X equal plus or minus, don't forget plus or minus 1. And x equal plus or minus again. But this is imaginary because it's a negative inside the radical. Entonces I square root 1/3. Yeah, you can leave it like that, but much better rationalization. Look, square root 1/3 is square root 1 divided by square root 3. Is 1 over radical 3. And rationalization multiply top and bottom by radical 3. Radical 3 times radical 3 is radical 3 over 3. It's nice. And the solution we can express like that. Plus or minus I Radical 3 over 3. Okay, so what is the solution? Say how many solutions? Well, we expect 4 solutions. Remember at the beginning I say 4 solutions. The solution set is, it doesn't matter the order. Plus or minus 1, you can write like that, and plus or minus I, radical 3 over 3. So we have 2 real solutions, real. This is real. And this is imaginary solution. And always is like that. No. In this particular example, it's like that. And sometimes happen if we have 4 real or 4 imaginary, but no. In this case, it's 2 real and 2 imaginary. In this specific example, no, is the answer for this specific example. Okay, I'm matching very well because it's a polynomial equation. Okay, the most important information I try to convey is the equation is polynomial. Degree is 4. We expect 4 solutions. However, this equation is more. It's quadratic form. It's a quadratic form because we can apply the U substitution. And the U substitution magically convert this polynomial equation to quadratic equation. And this quadratic equation I solve using the quadratic formula. And this, after you replace U for the value and solving 2 new elementary quadratic equations, and you get 4 solutions. Okay? It's confusing or it's clear? And we apply always when it's quadratic in form. How you recognize quadratic in form? Because you have 2 exponents. And the exponent, the big exponent is twice the smaller exponent. Okay? Okay. May I erase the board?
Yes.
Yes.
Okay. Let's do another. I have 2 more quadratic from. Look, this is. Wait a second. This is more. It's easier. It's x raised to the 2/3. This is exponent 2/3 fraction minus 7 x to the 1/3 plus 10 equal to 0. Okay, obviously this is no polynomial. Why no? Because when the exponent is fraction or negative, it's not polynomial. Only a polynomial when the exponent is a whole number. 0, 1, 2, 3, 4, 5. No negative and no fraction. However, it's quadratic from, yes. Why? How do you know it's quadratic from? Because this exponent and this exponent, the relationship is twice. So you multiply 1/3 times 2 is 2/3. So now it's obvious que es quadratic in front. And when it's quadratic in front, we can modification this equation to quadratic equation using the U substitution. U equal x to the 1/3. I always select the smaller exponent. And you rewrite now the new equation using U. It's a minus 7U because in my definition I declare that U is equal to x to the 1/3. And this is twice. Entonces U square. U square. And this new equation, let me rewrite again. U squared minus 7U plus 10 equal to 0 is quadratic equation. You solve it using the way you know. Okay, maybe quadratic formula, but in this case, no. Okay, so what is my recommendation? There are many ways for solving the quadratic equation. My recommendation is you spend 2 seconds to see if it's possible or not by factorization. Because factorization is easy, but it's weak. Entonces, si you don't see any combination, well, entonces we apply quadratic formula. Okay. Quadratic formula. In this case, I suppose it's easier by factorization. Yes or no?
Yes.
Yes.
What is the combination? Okay, putting
5
off.
and 2.
5 and 2. Very well. Putting off the microphone, please. Okay. 5 and 2, she said. 5 and 2, 5 and 2, 5 and 2, 5 and 2. What sign, miss?
-2 plus 5.
No. Both negative, right? Why? Because -5 times -2 is +10. Exactly like that. And -5 plus -2 and -7. Like this. Make sense? Make sense?
Yes.
Now, u minus 5 equal to 0, or u minus 2 equal to 0. That means que u is 5 and u is 2. And leave it like that? No. No. I need to find x value. I'm going to find the x value. Well, I come back to the substitution. Okay, you split the paper into part, u5, u2, and you copy that. So this is, okay, this is x to the 1/3 equal 5, x to the 1/3 equal 2. And so you need to remember what means fraction exponent. Fraction exponent is equivalent to, say, cubic root. Numerator is this power, 1, and denominator is the index of the root, que es 3. Cubic root, x equal 5. And likewise, cubic root, x equal 2. Entonces, in this moment, we have two radical equations, two new radical equations, que come from to the original. But it's easy. It's easy. You raise to the cubic power because, you know, the opposite to the cubic root is third power. It's equal 5 times 5 times 5, get 125. And here is 2 times 2 times 2, que is 8. And very important now. You have to check in this in the original equation. No. Why no? Bueno, professor, you say que when it's radical equation, es mandatory checking. When it's mandatory, when the index is even. Pero si the index is odd, like this example, que es 3, no, this solution is perfect. Never we have a extraneous solution when the index is odd number. Si es 3, si es 5, si es 7, no checking, no necessary checking. Si es 2, si es 4, si es 6, even, yes, you have to. You have to. Okay, so now in this example, let me summarize so far. We have one equation in, how do you know? Because we have two exponents. The first one is 1/3 and the second one is 2/3. Entonces I saw que es twice. Entonces when it's twice, it's quadratic form. We can transform it using the U substitution. Entonces using U substitution, when you are doing that substitution into the original equation, you transform it to the red equation, and the red equation is quadratic equation. In this case, I make a decision because it's easy. You know, I saw the combination. See, I don't see the combination, guys. Don't worry, because you apply quadratic formula and you get exactly the same answer. The only disadvantage is que it's too long. Pero no, it's okay. It's okay. You get the same answer because this is mathematics. It's the exact sign. You get 5 and 2. Finally, I come back to the substitution. I realize que it's a radical equation, two radical equations, but in this case, the index of the root is odd number. Entonces es nice. You raise to the cubic power both sides, you get the solution, and solution set for this equation is 125 and 8. Any question, guys? Say again? No? Oh, yes.
Where do you when the number is even, not odd?
The thing is, when you have, okay, good question. Let me explain it. Suppose you have one equation like that. Square root equal square root any expression equal 10. Well, this is a radical equation. You square both sides. Nice. This is any equal 100. Because 10 times 10 is 100. This equation is not equivalent 100% to the region. This and this is not equivalent 100%. Because the index of this radical is 2. Like what happened when it's 4, when it's 6. So when the index is even, you have to check it. When the index is odd, suppose cubic root any expression equal 10. Whatever, you cube both sides, any expression equal 1000. And this equation is 100 true equivalent to the original. Okay, the original was cubic root any equal 10. This and this is the same. Equivalent 100%. This is no equivalent. So si es no equivalent 100%, you have to check it. Mandatory. Here. But this is not checking. More clear now?
Yes.
If you want, you checking. And you get, oh, it's true, perfect. But you waste time. I guarantee 100% to you that when the index of the root is odd number, 3, 5, 7, 11, 9, no problema. When this 2, 4, 6, maybe yes. Let's see in the next example. In the next example, you see one very example to illustrate this idea when it's even. It's even.
Look.
Go ahead.
Oh, sorry. I left my computer died.
Okay. Do you want to get okay. It's okay?
Yes, thank you.
No problem. Remember, guys, this is a recording y I post en YouTube, ¿no? Pero no, okay, we have time, ¿no? Okay. I can erase now? You let me know.
Yes, I got it. Thank you.
Okay, super. Okay, this is an interesting example. Look, this is another equation, quadratic in front. Solve this equation. You see that the variable contain two exponents, 1/4 and 1/2. And es obvio que 1/4 multiplied by 2 is 1/2, ¿no? Okay, entonces that confirms our idea de que this equation is quadratic in front, ¿no? Okay, entonces you apply U substitution. U is equal x to the 1/4, que es a smaller exponent, ¿no? You rewrite 0 is equal 7 minus 7, 13u. Because I declared que x to the 1/4 is u, and this is u squared. That is minus 2u squared. And this equation is obviously quadratic equation. Okay, this is the magic of the quadratic form. Okay, using u substitution, you transform it in quadratic equation. A is 2, B is 13, negative 13, sorry. And C is negative 7. We can use in the quadratic formula, or we can do factorization. No, I prefer quadratic formula. When the A is no 1, I prefer it. So we using the quadratic formula, minus B plus or minus square root B squared minus 4AC divided by 12. Okay, B is negative 13, and negative of the formula becomes 13 positive. Plus or minus square root negative 13 squared minus 4 multiplication by 2, que es 6, multiplication by negative 7, que es C, divided by 2 times 2. Entonces, you know very well que in the quadratic formula, the order of operation, you should do first the operation inside the radical. The reason I do that first is because the radical is considered like a grouping symbol, like a parenthesis. Entonces, they have the higher priority. Okay, entonces now you put in a calculator, negative 13 is 169 positive, no? And be careful, double negative, negative, together plus something plus 56, because it's 8 times 7, no? And this is 225. And now square root, everything. Guys, it's obvious. Okay, anytime we can use a calculator, okay? Now, we come back to the red color, 13 plus or minus 15 divided by 4. 2 times 2 and 4. You separate in two pieces, 13 plus 15 divided by 4. And 13 minus 15 divided by 4. Okay, this is 28. Divided by 4 is 7. And remember, this is not the answer. This is U value. This is my first U value I get after the. And this is negative 2 over 4. Okay, negative 1/2. When you reduce and lower term, equal U. You have two values of U. I restore the black color. Because I go back to the original. U equals 7 is my first solution. And U equal negative 1/2 is my second solution. No? I want to manipulate, but I know that U is 1 over 4, que is equivalent to say 4 root. 4 root of x equal 7. And 4 root of x equal negative 1/2. Okay, this is equivalent. So x equal, so U is equal 4 root of x, no? Que es equivalent to say 1 over 4. Okay, entonces, in that moment, we are in front of two new radical equations. But be careful, because this radical equation, the index is even number 4. So maybe, I don't know if it's true or no, we have a strange solution, maybe. This is a possibility, no a real statement. No, so okay, I have no idea, I try. So you raise to the 4 power both sides. X is equal 7 to the 4 power is 7 times 7 times 7 times 7. If you put in the calculator, it's 2,401. And this is my first potential solution. Likewise here, you raise to the 4 power, both sides. X alone is 1 over 16, positive, because when you raise to the even exponent, the answer is positive. And so we have two potential solutions que mandatory you need to check in, because in one moment of the problem, we are working with the radical equation, and this radical equation, the index is even, therefore maybe yes or maybe no, we get extraneous solutions. You check in both and the original equation. The original equation, remember, I never change the color, it's black. This is the original equation. Okay, so let me rewrite. So let me try to check in for x equal to 2,401. So says 2, I copy the original, but I copy using radical notation because I feel more comfortable with the radical notation like the fraction exponent. 2,401. So instead of this, no. I copy like a square root. And this is minus 13. And this is 4 root. 2401 minus 7 should be 0. Si we guarantee that this is 0, this solution is good. Okay, and remember where come from 2401. 2401 come from the multiplication 7 times 7 times 7 times 7. If you find the square root, you select by couple of 7. This is 1 7 and this is another 7. It's 49. So for the square root 2401 is 49. So 2 times 49 minus 13 times something. For root is different. You select no a couple. You know, you select 4 by 4. It's 7. It's just 7. Minus 7. Of course, I do by hand here, but no, you can put it in the calculator. That's it. Okay, your multiplication now is 98 minus 91. Multiplication minus 7 equals 0. 98 minus 91 is 7. 7 positive minus 7 is 0. Wow, fantastic. 0 equals 0. True. That means that the solution 2021 is good. Let's check it now. And the 1 over 16, no? Check. X equal 1 over 16. Similar. Similar as 2 times square root 1 over 16 minus 13, 4 root 1 over 16 minus 7 should be 0. I put a question mark because I'm not sure that this statement is true or false. Let's focus it. It's easy because look. Square root 1 over 16 is equivalent square root 1 divided by square root 16. Square root 1 is 1, square root 16 is 4. 1/4. 2 times 1 over 4. Okay, by the way, it's 1/2. Okay. Minus and 4 root 1 over 16 is 4 root of 1 and 4 root 16. 1 is a magic number. In any power or any root is always 1. But 4 root 16 is 2. Because 2 times 2 times 2 times 2 is equal to 16, right? So 13 multiplication by 1/2. Minus 7 should be 0. This is 1/2, right? Because you reduce divided by 2, 1, divided by 2 is 2. Minus 13 over 2 minus 7 should be 0. Well, as you find the least common denominator is 2. Is 1 minus 13 minus 14. So multiplication 2 times 7 is 14 is equal to 0. I suppose that this is complete. It's wrong, no? Okay, this is 1 minus 27, no? 27 divided by 2 is obvious it's completely false. This is statement, no? Because this is 26 minus 26 over 2 is the negative 13. And negative 13 equal to 0, completely false. Therefore, the answer 1 over 16 is wrong. I verified that. And the solution set for this equation is only, solution set is only one, case 2401. Boom. Final answer. Any question, guy?
How'd you get 14?
How you get 14? This is the classical fraction. 14 comes from multiplication 2 times 7. 2 times 7 is 14. Okay? Because 14, okay, look at that. You find the LCD. The LCD is 2. 2 is 1 minus 13 because they are perfect coincidence. But you know, and 7 the denominator 1. 2 divided by 1 is 2. And 2 times 7 is 14. So actually, si you are doing backward and you split, it's 1/2 minus 13 over 2 minus 14 over 2. Okay, this guy is 7. Do you see that?
Yes.
Excellent. Any question in this complicated problem? No?
No, thank you.
Okay. So we spend the time now for solving inequality that we need in the semester. No equation anymore for the moment, no? Inequality. For example, the most important thing you need to remember in the solution for the inequality. So inequality is, you know, solving inequality. Okay. The inequality, you know, instead of equal sign, you have that symbol, no? Less than, greater than, that symbol is less than or equal to and greater than or equal to. Are you familiar with this, right? Yes or no? You remember, no? That symbol.
Yeah.
Well, go ahead.
No, I was just saying yes.
Okay, super. And now is the difference with the inequality is in the equation we have one solution, two solutions, but it's just a point. However, in the solution for the inequality is no point, it's an interval. So what is the possibility of representation of the inequality solution? Let me try. Representation of the inequality solution. There are different ways to represent. The first way is one way, let's call it set builder notation. Another possibility is graphic notation. And another possibility is interval notation. Okay, by the way, guys, this is the most popular. In the test, always I ask you interval notation. Maybe in Alex, no. Maybe another, no? But the most popular is interval notation in the test. Let me put an example. And let me explain the idea behind this. Okay, look, solving the notation, you open that symbol, curly bracket, you put the name of the variable that participate in the inequality, suppose x, such that this stick represents such that x is greater than 2. Okay. What is the representation in graphic? Graphic representation is, look, this line represents all real number line from positive infinity to negative infinity. 0 in the middle here, and this is 2. 1, 2 is a bunch of value greater than 2. This to the right, and not included 2. And the way to indicate that not included 2 is using parentheses. So parentheses in Alex using that symbol, circle empty or circle full. It's circle full is bracket and circle empty is parentheses. So do not include 2 because you know we do not include because we have no equal sign here. No equal sign, no include. Okay. And the interval notation is easy. It's open parenthesis, 2 comma infinity. Infinity is a number. Infinity is a symbol que indique us que this line continues forever in that direction. And negative infinity is a continue forever in the next direction, the left direction. Okay, this is example 1. Everyone following, right? Another example. Suppose y, the variable is y now, such that y is less than or equal to -1. And close the curly bracket. Now let's do in the number line. The number line is okay. Infinity positive, infinity negative, 0 here. And this is -1. -1 here. And this is less than. Less than is this bunch of value, this interval. And of course, including -1, that's me. Okay, a symbolic way to indicate this idea is bracket here. Or full circle. Okay? Close. And this is open, close. And now, in interval notation is from negative infinity, comma -1, bracket. Okay, you understand now. Next example. This is just example, guys, to illustrate the representation. After we go over to the solutions. W, another variable, such that W is in between 2 and 4. Infinity positive, infinity negative. 0 here, 1, 2, 3, 4. It's a bunch's value in between 2 and 4. Of course, not included 2, because I don't see equal sign here. Therefore, the representation is using parentheses and square bracket, because include 4, because I see. And the interval notation is parenthesis 2, comma 4 bracket. Super. One more example, and that's it. Suppose now another variable z, such that c is less than or equal -2, or c is greater than or equal 3. Okay. Okay, infinity positive, infinity negative. 0 here. 1, 2, 3. 1, 2, -2. Okay, this part is the bar. Of course, consider the bracket here. And this part is this part, greater than, to the right. And again, bracket. Okay, this is the representation. How you represent interval notation? Well, it's from negative infinity. Actually, we have 2 pieces separately. From negative infinity to -2, parenthesis bracket, union, you put the big U, is equivalent to or, in this notation, or, and union is the same. Bracket 3, comma infinity. Okay, this is a symbolic way to represent the solution for the inequality. Normally, we need to memorize the 3 different ways. However, the most popular is the interval notation. Always in my test, I say, express the answer in interval notation. Okay, and the rest is similar to the question. No. We need to obey some rule. For example, if you rule number 1, to solution for the equation. Rule number one. Rule number one is if you multiply, if you multiply for some reason, multiply or divide by negative number, you must reverse it. Reverse the direction of inequality sign. Let me illustrate this idea que es super straightforward. Suppose you have 2x greater than 4 and minus 2x greater than 4. You divide by 2 both sides, similar to the equation, and nothing happens, stay the same. 4 divided by 2 is 2. However, in this case, no. In this case, you divide by negative 2. So say x is equal, 4 divided by negative 2 is negative 2, but you have to reverse the inequality sign. So when you divide by positive number, stay the same. When you divide by negative number, divide or multiply? Multiply or divide by negative number, you have to reverse it, the direction of the inequality. This is rule number one. Rule number two is easy. Is suppose that for some reason you need to interchange the inequality. For example, you have this is inequality is easy. Suppose you have 2 is I don't know, less than x. But to express anything for me is more countable. Put a variable in the left and the number in the right. And so you, for example, you put an x in the left, you put a 2 in the right, and you reverse the direction of this. This is one, one idea to understand this. Another possibility is, well, okay, Professor, you explain me the division by negative. Okay, to say, for example, see, I move this guy to the left and negative. You move these 2 to the right and negative. Now, finally, divided by negative 1 both sides. So x positive and 2 positive, and you reverse, and you get the same result. Okay, I don't know, you memorize the rule number 2, okay, it's only interchange and reverse the sign. It's obvious, right? Or the rule number 1 only, okay, is you move in the corresponding side you want and multiply or divide by negative 1. Let's do a couple of the inequality, and we take advantage and express the answer in interval notation. May I erase or no? Guys, let me know if I'm doing too fast. I know. These classes, it's intensive. Remember, it's 2 classes inside 1 class. The lecture is 2 hours. And so now is, I don't know. I suppose that this is super easy, but okay, it's just refresh your memory in that part of the algebra because we are using every day. Okay?
It's good review.
It's good. Okay. You let me know. You're my student. You are my customer. Entonces, si professor, you are doing too fast. I don't understand anything. Okay, it's clear for me. Okay, now chat. Activate the microphone and tell me any issue. Okay, when that happens in the whiteboard, I don't see the chat. All right, let me see the chat. How? Well, okay. Let's continue in the whiteboard. Do you see whiteboard, right? Okay, let's see a couple of the examples. easy of the inequality, no? Suppose this inequality. Example inequality. Example 1 and example 2. We have two examples. Suppose this -6 less than or equal 3 plus 1/3 x less than or equal 5. Okay, actually, this is compound inequality because we have two inequality actually, no? We have that part, look, is one inequality, and we have another part, is this inequality. And when you have two inequalities together, it's called a compound inequality. But it's okay, don't worry, because we can solve simultaneously both. So we can separate both gen 2. Yeah, you can, of course. And in this case, you connect them by and. Remember, it's conjunction and or in this case, and. However, no. In this case, no. It's a three-part inequality you can solve simultaneously together. Now, what should I do? Well, easy. You subtracting 3 here. Because my goal, remember, is solve for x. You subtracting 3 in order to remove that 3. It's a -9. This cancel out. This is the intention. And this is 1/3 x less than or equal to, no? 5 minus 3. Now, finally, I need to remove somehow this coefficient because I need x alone, no? So you multiply by reciprocal. What is the reciprocal? 1/3, 3. So you multiply the whole thing by 3. It's a -27. This is x. That's the intention because these 3 and these 3 cancel out. And 3 times 2 is 6, no? And what happened with this sign? Stay the same or reverse it? Oh, it stayed the same, Professor, because we are doing the multiplication by positive numbers. How you express the answer in interval notation? Well, bracket -27, 6 positive. And both bracket because this equal sign indicate us que incluye the endpoint. Super easy or super complicated? Opinion. Another easy. 10 less than 5x less than or equal 25. Well, in this case, it's easy, in my opinion, easier. Because the only thing you should do is divide by 5, both sides. 10 divided by 5, 2. 5 divided by 5 cancel out, it's just x. And it's a 5. Less than or equal 5. And the representation is parenthesis 2, 5 bracket. Equal sign, bracket. No equal sign, parenthesis. Make sense or no?
So if it's greater than equal to less than 2, it's bracket.
Absolutely. Bracket is when you have equal. Because the representation, let me show you, mister. Look. Suppose I want to represent graphically to understand. You know, one picture is much better than 1,000 words. This is infinity. This is negative infinity. This is 0, 1, 2, 3, 4, 5. Es the interval que es en between 2 and 5. 2 and 5 is the endpoint. But we have no equal sign here. Maybe then, maybe no, for sure, no included 2. And 5, yes, equal sign included 5. Make sense?
Yes, it does.
Let me see. Any other question? Remember, it's my pleasure answer any question. Yes, my satisfaction when you say, yes, I understand. May I erase or no?
Yeah.
Okay. Let's move on to the last part of today, que es equation and inequality equation and inequality involving absolute value. Equations and inequality that contain or involving whatever absolute value. Let me recall what is the absolute value. Absolute value, the symbolic way to indicate absolute value is this bar. Absolute value, any number, absolute value 3, for example, is 3. The absolute value negative 3 is also 3. Why? I don't understand this. Because the reason is because absolute value represent distance. Look, this is again our number line. This is 0 in the middle. 1, 2, 3. 1, 2, and negative 3. Okay, the representation, the interpretation, this absolute value indicate distance. Distance is, look, the distance from 0 to 3 is 1, 2, and 3 steps. And what is the distance between negative 3 and 0? Always the reference is 0. Is exactly the same. 1, 2, and 3. 3 steps. And when you're talking about distance, this word is important. Distance is always positive quantity. That is the reason it's always positive. The student memorize quickly because absolute value somehow remove the sign. See, a positive is a negative positive. But this is the interpretation. Distance. What is the distance between Homestead and Hialeah? 20 miles. What is the distance between Hialeah to Hunting? 20 miles. I don't care the direction. I care the amount of miles that separate both cities, right? Distance is always positive quantity. This is the interpretation of absolute value. Therefore, suppose that we have this equation, elementary equation. Absolute value x equals 3. It's obvious that this is equivalent to separating two equations. X equals 3 or x equals minus 3. So we have two solutions. So this is the idea behind the solution of the equation that contains absolute value. Look, let me show you. Suppose that we have, what is the formula? What is the algorithm? The formula is you have absolute value, any expression, equal any number, suppose 10. And well, immediately I know, okay, this is equivalent. This symbol indicates equivalent. You copy the any expression equal 10, so you somehow remove the bar, but no arbitrary, or so now you put any again equal minus 10. And you have two equations and you solving separately this equation. Okay? Some people I saw every day in the test. Suppose absolute value 2x plus 5 equals 7. And the people say, no, I don't care. This bar, 2x plus 5 equals 7. This is wrong. This is wrong. Totally wrong. Okay? Don't do that. Anything. Okay, no, never. Don't do that. Okay, suppose example to understand more clear. Suppose example 1, equation. Suppose absolute value 2x plus 1 equals 7. Typical question in the test. Solve that. Well, I know that this is equivalent to, right, 2x plus 1 equals 7, or another equation that is 2x plus 1 equals minus 7. It's super easy. You remove the bar, look, remove the bar, and it's obvious, okay, you copy exactly like that. and you copy, remove the bar one more time, you put -7. And you solve it separately, this equation. Let's do it. 2x x equals 7 minus 1. 2x equals 6 divided by 2. X equals 3 is my first solution. Here, 2x equal minus 7 minus 1. 2x equal minus 8 divided by 2. X equal minus 4. Then we have two solutions. The solution are positive 3 and negative 4. Solution set for this equation is 3 and negative 4 or negative 4 and 3. Doesn't matter the order. Do you follow me?
Yes.
Excellent. Let's see example 2 to clarify a little bit more. Example 2.
I'm sorry.
Go ahead.
Could I see the first one? Second.
Second?
The top.
Yeah.
Thank you.
For these ones, to check it.
Say again.
For these ones, check it.
Bracket, no bracket. It's equation, miss. It's equation, and the And when you have equation, the solution set for the equation, you listing. You open that, and you list the solution is something separated by comma. It's in the equation, and the bracket or parenthesis is in inequality. Okay.
Oh, I was asking if we don't have to check it. Like,
No. So far, the only bad guy that you need to check in. Okay, wait. Listen to me. So the only bad guy that you mandatory need to check in is the radical equation. But in general, you say, well, you want to make sure that you are doing okay. You plugging in the solution into the equation, and your verification is true statement. But this is not mandatory. It's to make sure. The only guy that is mandatory is a radical equation. Why? Because in the manipulation that you are doing, you transform the equation, and the new equation is not 100% equivalent to the original. And you, not intentionally, but you introduce mistake in the equation, right? Therefore, you need to check it. And the radical equation is the only, so far. I promise que in the next chapter, you see another equation que contain the same problem. Is clear this idea or no?
Yeah.
Excellent. Beautiful. Let's move on to example 2. In my opinion, is very interesting because bring me new situation. Suppose x plus 3 absolute value. We are solving, guys, equations that contain absolute value. Okay, entonces now, what should I do? You apply the rule that you studied before? No, why no? Because you must isolate first. So the first step is you have equation that contain actual value. You isolate the expression that contain the actual value alone, totally alone, 12 minus 5 is 7. And now this is a crucial moment to apply the rule. The rule say, wow, you copy x plus 3 without a bar equals 7, or x plus 3 equals -7. And you solve it separately, both equations. That's it. X is equal 7 minus 3 is 4. And here is x equal -7 minus 3 is -10. Well, the solution for this equation is 4. Ugly. 4 and -10. Or -10 and 4 either way. Do you follow me? Excellent.
Yep.
Excellent. Beautiful. Okay. That's it, no? We have more complications. Look. Let me explain another example 3 is very, very, very important. Look, example 3. Example 3 is actual value 5x minus 3 equal negative 4. Entonces the student try to apply immediately the algorithm. You remove the bar. No. Because conceptually, this is a contradiction. Why is a contradiction? Because I explained at the beginning that absolute value represents distance. I explained at the beginning that distance is always positive number. Therefore, this is the distance. And see, the distance is positive number equal negative number. This is a contradiction. Therefore, this equation has no solution. No solution. You don't need to do anything. Only no solution. When you see that the right-hand side is negative. When you see that the right-hand side is negative, this is a stupid equation. No solution. It's negative. This is a contradiction. But not always this is elementary. This suppose I do something like that. Look, suppose absolute value of 5x minus 3 plus 10 equal 6. So you see 1, okay, right hand side is positive, is 6. We have solution. No, why no? Because the first thing you should do is isolate that part. So you move 10 to the other side, 6 minus 10 is 4. And you come back again to the same stupid problem, no? No solution. Okay? So first of all, when you face one equation that contains absolute value, the only thing that you should do is isolate the expression that contains absolute value. Everything move numerical part to the right hand side. See, the answer is negative. Immediately I recognize there's no solution. Since the answer is positive, no, we have solution, of course. We see before. Okay. One more. Suppose this. Example 3. Example 4, sorry. Example 4. Equation. Suppose 7x minus 3 equals 0. Ooh. Another case, equals 0. Remember, this is distance. Again, this is distance. You write something in the chat? Let me see. No. Okay. And distance should be 0, of course. 0 is possible. However, in this case, you have only one solution because, okay, suppose that you don't understand very well. Well, you have solution, yes, but how many? One solution or two solutions? Well, suppose that you apply is you remove the bar equals 0 or 7x minus 3 equal minus 0. Have no sense to talk about minus 0. 0 have no sign. 0 is just 0. Therefore, you remove, in this case, when the right-hand side is 0, we have only one solution. Is, well, you move 3 to the other side, 7x equal 3 divided by 7, x equal 3 over 7. In conclusion, see, I summarize everything. Guys, stop the comment, okay? We have three possibilities in the equations. When the right-hand side is positive, we have two solutions. Look at this example and this example. Two solutions. When the right-hand side is negative, no solution, 0 solution. When the right-hand side is 0, one solution. It's easy to memorize this. It's clear? It's clear or no?
Yes.
Yes.
Okay. Let's move on to the inequality now involving absolute value. It's a little bit more complicated inequality. But why is more complicated? Because we have two cases. Case one, case less than. Suppose. Less than is actual value x less than 3. I put 3 like an arbitrary number. So what is the interpretation of this? What is the interpretation of this? The interpretation is, let me show you. This is my number line. This is infinity positive. This is infinity negative. This is 0 in the middle. 1, 2, 3. 1, 2, 3. This is 3 positive. This is 3 negative. Solution of this inequality is exactly the value in between 3 and negative 3. It's easy to understand the interpretation of this because this is distance. One more time, this is distance. Entonces, when the distance is less than 3, it's because it's near. Suppose que es 3 miles distance. Entonces, 0 is solution, 1 is solution, 2 is solution, negative 1 is solution, negative 2 is solution, and the middle decimal 2.5, negative 2.5 is solution. And therefore, when you see less than case, okay, the interpretation, this is equivalent to say x in between 3 and negative 3. And this is the formula that we are using to solve. So basically, you convert this inequality in one compound inequality. And you solving exactly the same we are doing before. I promise in a few seconds I solving some questions, some example of this. No, this is less than case. But you understand it's near, right? Because it's less than. And si es greater than, it's different. Yeah, you need to be aware for that situation. The case greater than. Boom, boom. Okay, again. Well, no necessary to do again. Greater than is too far. This is the distance. It's actual value x greater than 3. This is distance again, right? This is distance again. Si it's distance, then the solution is different. It's here. Too far. 3 miles. So the solution of this greater than is the green part. So this is equivalent to say. This is equivalent to say. Is x less than minus 3. Que es that part. Or because it's 2 interval, is x greater than 3. Que es this interval. And this interval, que es the yellow, is in between, x in between, minus 3 and 3. Yellow and green is 2 green. So actually, the solution contains 2 intervals. This interval and this interval. How you write that in interval notation? Well, you write like that. From negative infinity, comma, negative 3, parenthesis, union, 3, comma, infinity. Boom. And this is the formula. Okay, the formula is that formula. Entonces, when I grade the test, y I grade the test that part, I need to know, so I immediately checking, see in one problem of the less than, you copy only one interval, it's okay. See in one problem of the greater than, you copy 2 intervals, it's okay. And some people know, so some people confusing that, and to say now you see that in one problem of the greater than is 1 interval. No, it's 2 intervals. And one problem of less than 1 interval. Yes. Okay. This is clear or confused? Okay, slow down. Let's do an example 1 of the inequality that contain absolute value. Example 1. Suppose this. Absolute value 2x plus 1 less than 7. So immediately you identify, wow, es less than case. Entonces, ¿es one piece o es two piece? ¿Es de yellow o es de green?
Yellow.
Yellow. Therefore, immediately I know that this is equivalent to write 2x plus 1 with a bar and between 7 and -7. End the story. In this moment, you have a compound inequality and you're solving this compound inequality. Subtracting 1. Divided by 2. And when you divide by 2, and -4, this is x alone, and this is 3. And the sign stays the same because it's obvious that you are divided by a positive number. However, in the test, no. The test I ask you specifically. Express your answer in interval notation. 1, okay, es paréntesis. -4, 3. Boom, final answer. You follow me? You follow me? Let's do another example. Example 2. Example 2 is actual value of x plus 5 minus 2 less than 12. Well, this is similar, no? It's less than case. So when you finish this problem, we expect one interval, no two intervals, only one. Entonces, but what should I do first? Want to use isolate the actual value expression less than 12 plus 2 que 14. Okay, now this is a moment, the most important moment in which you remove the bar and you convert to compound inequality. 14 positive and 14 negative. Okay, subtracting 5. Negative 19. X, this is cancel out that part. And this is 9. Okay, but in the test, I want in the interval notation is parentheses, negative 19, 9. Okay, the answer. Everyone follow me? Okay, guys, I want to erase the board, right? Okay, another example. Suppose this. Actual value, 3x minus 1, less than or equal 11. Entonces, when I finish that, you expect one interval or two intervals? One piece or two pieces? Answer me.
Two pieces.
No, one piece because it's less than. Remember, yellow is less than. Green is greater than, two pieces. Yes or no?
Yes.
Entonces, okay, listen to me. Less than one piece. Greater than two pieces. So now it's easy. You remove the bar, 3x minus 1, and between 11 and negative 11. You transform this original problem in this compound inequality. And the rest is okay. Addition 1, addition 1, addition 1, negative 10, 3x, 12, divided by 3. Negative 10 over 3. X, and it's a 4. And the answer in the test is present in interval notation is bracket, both bracket, negative 10 over 3, comma 4. Bracket, because it's equal. Okay? Okay. One more. Suppose this. Absolute value, x plus 3 plus 5 greater than or equal to 12. Okay, when I finish this problem, we expect 1 piece or 2 pieces?
Two pieces.
Exactly. How do you know, miss?
Because it's great.
Because it's greater than. Okay, but what should I do first? Always, when you face one problem of the absolute value, isolate the absolute value expression. Boom. Now, you convert this to compound inequality. How? Remove the bar or 2 pieces. Okay, the only transformation that I should do is remove the bar, stay the same, but this is reverse this and put -7. So the right hand side positive and negative, and opposite sign. Okay, let's solve it separately. Is x greater than or equal 7 minus 3, x greater than 4. I copy this answer. And x less than or equal minus 7 minus 3 is negative. Okay. See, I need to understand much better this answer. Well, okay, I represent graphically. Zero in the middle, I suppose 1, 2, 3, 4, and negative 10 is here, approximately. So this statement, this bar is that bar. Include 4 bracket here, and continue forever in that direction. However, that part, maybe using another color, blue maybe, is that part, less than, to the left. Include negative things, so be right, and continue forever in that direction. This is not mandatory to do that. I like, personally, but no mandatory. Basically, the answer I want in the test is negative infinity, comma negative 10 bracket, union bracket 4, comma infinity. Boom, final answer. Any question? Any question? No?
No.
It's clear, right?
No, at the moment.
Say again?
None.
Okay, super.
Professor, do you think we could go back to radical equations and just do another example?
Okay, which one? Previous?
Yes.
Okay. You say this one, absolute value, 3x minus 1, less than or equal 11. Yes, this one. You say, miss? Miss?
No, the one with like quadratics.
Oh, no. We continue the sequence. We're doing it. Quadratic after that. Remember, guys, today is theoretical part. However, I go back again over everything we are discussing in the review package, okay?
Okay, thank you, Professor.
My pleasure. Okay, entonces the 5 minutes that we have, because we finish always at 11, because I need to prepare the next class that I have now. is some special cases. Some special, well, special is when you have, for example, this guy, actual value, x minus 10, minus 2, less than or equal minus 3. Suppose I put in the test something like that. I never put in the test something stupid thing, but when, okay, it's actual value x minus 10. You isolate the actual value is less than minus 3 plus 2 is negative 1. So what do you think? Negative 1. What do you think? We have solution or no solution? No solution. Because the right hand side is negative, and this is a contradiction, no? It's a contradiction, never is negative distance. And be careful, because it's the symbol I changed a little bit. Look, let me explain this idea, and that's it for today. Suppose actual value x minus 4 plus 5 greater than or equal 4. Suppose in the test I put something like that. So is actual value x minus 4 greater than 4 minus 5 is negative 1. And you see, wow, one more time, right hand side is negative. Immediately you see, no solution. No, be careful. In this case, different. Entonces, this is distance. And the distance I know always is positive. And positive number, distance represent positive number. And positive number is greater than or equal to negative 1. Bueno, equal never. Si es positive number, equal negative 1, es obvio que es contradiction, totally contradiction. Pero positive is greater than negative 1 is true. This is false. Therefore, and remember that symbol indicate greater than or equal to. So the greater than is false, but the equal is true. See, at least one statement is true, and we connect it by or, the statement is true. Entonces, it's true. It's true. We have solution. We have solution. And when it's greater than, be careful, we have solution. And how many solutions? Infinity many solutions. O sea, the solution is all real number. It's from negative infinity to positive infinity. Do you understand this or no?
Yes.
So be careful. Inequality is a little bit picky and complicated. When you have a negative number in the right hand side, and si es less than, definitely we have no solution. But when it's greater than, we have infinite many solutions, que es all real number. Okay, guys, just stop. I don't check in the Alex, but I suppose that everyone is already registered, no? In Alex, no? And start working in the homework. Any question that you have, I have a new schedule for the tutoring. No Friday, it's Wednesday. Wednesday, I am in the virtual tutor from 11 a.m. to 5 p.m. Okay, new schedule is Wednesday, 11 a.m. to 5 p.m. Okay, and here, if you have any question, you have doubt, question about the homework. So what is my intention? My intention is that you start now doing the homework. Homework 1, 2, and 3 in Alex, no? Forget about the rest. Okay, now, when you feel strong, you take the test. The test is due February 1st. Okay, after the February 1st, the test is frozen. And I put this grade in the blackboard. Okay, so you are doing nothing, you have 0, no? You are doing something, I put the grade corresponding for you. And before February 1st, I will send by email the test, the reading test. So the test on paper. Are you clear on this, no? Are you clear, right?